All right, today we are going to look at solving equations involving exponents.
All right, so when we're asked to solve an exponential equation, our goal is always going to be to try to make the bases on both sides of the equation the same. Take a look at this property here. If b is raised to the power of m and it's set equal to b raised to the power of n, well, then by default, m has to equal n. So this statement simply says that if the bases are the same, the exponents have to be the same for it to be an equivalent equation. Now, to solve an exponential equation with the same base, first we need to rewrite each problem using the same bases. So not every problem that I'm going to throw at you guys today is going to have the same bases. However, you should be able to use your rules of exponents to rewrite each side so that the bases are indeed the same. And once you make the bases the same, we can drop the bases and set the exponents equal to each other. Here are the steps for how to solve any exponential equation by getting both bases to be the same. So step 1 says determine if the numbers can be rewritten as the same base. Again, sometimes you might have to use some of your rules of exponents to rewrite the bases so that they are the same. If you can't rewrite the bases the same, we're going to learn how to do that in our last unit, which involves logarithms. Step 2, go ahead and rewrite each side of the equation using the same bases. Step 3, use the properties of exponents to simplify the problem. Step 4, once the bases are the same, we can simply drop the bases and set those exponents equal to each other. And then finally, step 5, finish solving the problem by isolating the variable. Consider this first example. We have 2 raised to the power of x plus 6, and it has to equal 2 raised to the power of 5. Now you can see here both bases are 2. Since the bases are the same, we can simply get rid of those bases and set those exponents equal to each other. So that's what I have here. X plus 6 equals 5. So therefore, if I solve for x, I subtract 6 from both sides, and we're left with x equals -1. And you can always check these by plugging x equals -1 back into the original equation. So let's do that. 2 raised to the -1 plus 6 has to equal 2 to the 5th. And we can see here 2 to the 5th is equal to 2 to the 5th, and that's a true statement. So we know x equals -1 is a good answer. All right, in example number 2, we have 9 raised to the power of 2x minus 5 equals 27. So you can see now this problem has bases that are not the same. 9 is the base on the left side, 27 is the base on the other side. So our first step is to figure out, can I rewrite 9 as well as 27 as the same base? So take a minute and think about that. And hopefully you came up with, I can rewrite 9 as 3 squared and 27 as 3 cubed. So now both bases on each side of the equation is 3, and I can use my rules of exponents to help simplify this. So 3 squared raised to the 2x minus 5, I need to multiply those exponents since it was a power raised to a power. So now I have 3 to the 4x minus 10 equals 3 cubed. And since both bases are 3, we can drop those bases and set those exponents equal to each other. And we get 4x minus 10 equals 3. I can add 10 to the other side. So I get 4x equals 13. And then divide both sides by 4. And I get x equals 13 over 4. And again, you could plug that back into the original equation. 9 to the 2x minus 5 equals 27, and you should see that it's a true statement again. All right, and finally, I just got 4 practice problems I want to do with you guys. Looking at number 1, 4 raised to the 3x plus 5 equals 8 raised to the 4x minus 3. Again, these bases are different. However, you should be able to recognize that I can rewrite 4 and 8 so that they're the same bases using base 2. So 2 squared is equivalent to 4 times 3x plus 5 equals 2 cubed to the 4x minus 3. And since both bases are the same, I can drop those bases and set the exponents equal to each other. So I have 2 times 3x plus 5 equals 3 times 4x minus 3. And now I just need to solve. So I'm going to distribute on both sides, and I get 6x plus 10 equals 12x minus 9. Subtract 6x. Add the 9 to the other side. And I get 6x equals 19. Divide both sides by 6. And I get x equals 19 over 6. Again, you could plug that back into the original equation and verify that the left side equals the right. Looking at number 2, this one's a little bit more challenging. I have 8 raised to the 2x minus 3 equals 1 over 16. All right, there's a fraction for us, raised to the x minus 2. So somehow I need to rewrite base 8 and 1 over 16 so that they're the same. All right, now to do this, my hint is when you see a fraction, think back to your rules of exponents. One of our rules deals with fractions, and that is our negative exponent rule. Remember, a negative exponent I can rewrite as a fraction. So if I look at 8 and 16 in particular, I know I can rewrite those both as base 2. So 8 would become 2 cubed times 2x minus 3. And then 1 over 16, I know that 2 to the 4th is 16. But if I want it to become a fraction, I need to make it 2 to the negative 4th. Remember, our rules of exponents says if I have a negative exponent, I can bring in the base down and make it a positive exponent. So I'm going to rewrite 1 over 16 as 2 to the negative 4th, raised to the x minus 2. And now I can distribute this, and I get 2 to the 6x minus 9 equals 2 to the negative 4x plus 8. Bases are both the same. They're both base 2. Set those exponents equal to each other. So I got 6x minus 9 equals negative 4x plus 8. And let's solve this. Bring the 4x over. Add the 9 to the other side. And we get 10x equals 17. Or x is 17 over 10. All right, now looking at number 3, we got 25 raised to the x plus 1 equals 5 root 5. So I need to rewrite both sides with a base of 5. So 25 I'm going to rewrite as 5 squared raised to the x plus 1 equals 5 root 5, which is really 5 times 5 to the 1/2. We learned that yesterday, that a square root we can rewrite as a rational exponent of 1/2. And so if I clean this up, I got 5 to the 2x plus 2 equals 5 to the first times 5 to the 1/2. And coming back to our rules of exponents, when I'm multiplying and the bases are the same, what are we going to do with those exponents? We're going to add them. So 1 plus 1/2 is 3/2. And now both bases are 5. I can drop the bases and set those exponents equal to each other. So I get 2x plus 2 equals 3/2. 2x equals negative 1/2. Divide by 2. And I get x equals negative 1/4. And finally, our last question, number 4. I have 3 raised to the 3x minus 1 equals 27 raised to the x minus 4. So again, I want to rewrite these bases so they're the same. And I recognize that 27 is a perfect cubed. So I can rewrite it as 3 cubed. And since both bases are 3, I can set those exponents equal. So I have 3x minus 1 equals 3x minus 12. And the 3x's drop out, and I'm left with negative 1 equals negative 12. And since the variables canceled out, this is one of those special cases. And since negative 1 clearly does not equal negative 12, this is a no solution problem. Which means no matter what I plug in for x, it's never going to satisfy both sides of the equation.